Okay, good afternoon. Good afternoon, fellow Foundrymen. On behalf of Chennai chapter, instead of Indian Foundrymen, I welcome all the participants for this wonderful webinar. Gulab Patel, uh, Mr. Gulab Patel, Business Manager, Allied Refractory Products, Ahmedabad, is going to present us about the refractory on die casting practices. Refractory plays major role on uh, furnace life, the energy, and the product output and the quality as well. So in multiple angle refractory plays in die casting foundry. So to enhance our knowledge on refractory part, Mr. Gulab Patel is going to give us a wonderful presentation today. I request all the participants to attend the program fully and raise your questions at the end of the program so that Mr. Gulab will be in a position to give the answers for all the questions. So to introduce Mr. Gulab to the forum, I request our immediate past chairman, Mr. Saktivel, to introduce Mr. Gulab to the forum. Over to Sakti.
Thank you, Chairman. Good afternoon
Thank you.
to each and every Foundryman present today. I am with immense pleasure. I am introducing Mr. Gulab Patel to you. He is a business manager at Allied Minerals Refractory. He is currently designated as a business manager of Allied Refractory, associated with Allied for more than 13 years. So he has worked at a different position in sales and technical support. And also he has given a lot of write-ups in refractory solutions for ferrous as well as non-ferrous in different foundries, magazines, different foundry magazines published in India. So this is Gulab Patel for you as today's afternoon speaker for IIF Chennai. This is as per my knowledge, first time we are putting in a aluminum refractory technical program for the IIF Chennai, sir. So most welcome. Also one more request, Southern region is running a newsletter. So later you can send your presentation as a presentable, publishable article to us. So we can maybe next month we can publish this article, sir. So over to you, Mr. Gulab Patel.
Okay, thank you very much, Mr. Saktivel, and for a introduction about myself and little bit about the my company. And I would like to thank IIF Chennai chapter on behalf of Allied Refractory Products India, who has worldwide. So, as mentioned by Mr. Chairman, that refractory play a major role to achieve the goal. There is a lot of goal into the die casting foundries, and out of which there are certain equipments which is associated with the refractory. Without refractory, those equipments never exist. So basically, those equipments lined with the refractory are associated with the refractory directly play a major role not only into the ease of operational, but also directly relate to the cost of the production as well. So here we are going to just uh, find out, and I'm just going to share the points which are the areas where the refractive play a very, very important role. Also, along with the refractory, there are other operational factors where the practices which can be help out to die casting industries to reach their goal of having the best performance with their equipment, as well as uh, uh, to achieve the goal of a reduced production cost. So moving towards what we are going to discuss today is I will just go briefly on the company introduction, and then we will go ahead with the refractory and die casting foundry, how the refractory and die casting foundries and where the refractories play the major roles. What are the major goals by the die casting foundries? Then we will come to the lining part. Then we will discuss about some of the rapid turnaround refractory products. Then we will talk about some of the flooring as well as the best practices, and we will summarize with the conclusion. So going forward with introduction, Allied Refractory Products India is a wholly owned subsidiary of Allied Mineral Products, which is based in USA, Columbus, Ohio. Allied Refractory Product, that ARI, has the manufacturing plant in Shannon, where we have started our manufacturing facility operation in 2013. Before that, we are having the presence in India from 2007, but from 2007 to 2013, we are having our channel partners where we were having the stock from for all the products from our affiliates like US and China by importing it. But from 2013, we are right now manufacturing all the products at our India plant. So basically, the Allied Mineral Products, which is the principal company, which is founded in 1961. It means that we are a 62-year-old company, and we are having the presence in more than 130 countries. And currently, we are having the 13 manufacturing plants worldwide, 8 precast facilities as well. So, from the 61 until now, we have certain acquisitions like Matrix Refractories. We have done in 91. This is all about aluminum products where we are manufacturing. Then American Precast Refractories, Chicago Fire Breaks, Prior Gigi, Riverside Refractory. Those are the company we have the acquisition. Recently, in the recent years, GrafTech, and recently in 2020, that is the WAM, which is specifically a patented technology for the aluminum application. We have the Research and Technology Center into the Columbus, our head office in USA. We have in China as well, where our skilled team of the research and engineers and scientists develop all the new refractory technology products, which is going to be further improve the performances into the die casting foundries to achieve the best lining performance. We have almost 12 existing products, which is patented by the Allied. So coming into the second points, like how the refractory and die casting foundry is closely associated. So if you will see in your die casting foundry, the process starts from melting, where you can see mostly into the die casting foundry, there are tower type furnaces that called stack melter, and there are some places where the scalner is also. So it started from the melting. Then there are certain places through the lounder, small lounders, it molten metal just poured out into the ladles. And there are a different type of the ladle being used to transfer the liquid metal. So from the ladle, those liquid metal is going to be transferred to the die casting, holding and dosing furnaces. And from these die casting, dosing, holding furnaces, finally, the production start into the die casting. So these are the equipments which are directly associated with the refractory, or you can say it's aligned by the refractory products. And there are so many studies shows that basically the die casting industry is a very highly energy sensitive production. And the research and the experiences shows that in these melting, transfer, and holding, these areas consumes almost 60 to 65% of the energy being used to finally making the production. So it means we can understand that how these equipments are directly playing the role into the cost of the production. And these equipments, as we have been gone through that, if we will working on those equipments, the cost of the itself refractory is almost like 50-50. So we have to give a thorough and very focused attention on refractory products, because those are directly affected the lot of things, not only the operation, but also the cost of the production also. So moving forward, what are the major goals by die casting foundries? So the ultimate goal and always the top priority goal is how we can do the best with in all our process to lower the energy consumption. Then coming into the second point is the volume stability of holding liquid metal. When we are talking about volume stability of the holding liquid metal, uh, it is like we are starting from the melting, then transfer, and then putting into the directly into the holding furnaces. Those are designed specifically for certain capacity of liquid metal handling, holding. But after certain duration of the time, as the time passes, like 1 month, 2 months, whatever. So as the time passes, because of certain reasons, there is a lot of reason, but because of certain reasons, the volume capacity of those equipments got reduced. Like it has been designed for the 1 ton, but now after certain period of the time, it got reduced by to the 750 kg or 700 kg, whatever. So it drastically reduce if we are not putting our best effort to find out the right refractive product which is coming into the molten metal contacts. So and if the capacity got reduced, it is like that you design for 1 ton, but you are operating at 700 kg capacity, and the energy is going to be almost same. So basically, you are losing your energy. Then coming into the third point, less repair and maintenance, because means that is kind of the ease of the operation. If your furnace is or your lining is going to be reduced repair and maintenance, you will be having more time to run your furnaces. And if you are having the more time to run your furnaces, definitely you are going to have the more productions. Then again, longer efficient lining life. When we are talking about longer efficient lining life, means lining life is furnaces can run for 1 year, 2 year, 3 year, for depending upon kind of the product or kind of the configuration, refractory configuration, and there is a lot of factors associated. But when we are talking about the efficient, means when you have started your equipments, when it was a newly lined, there was a certain parameters which, like your steel cell temperature, your heat loss, and all those things. Those are going to be how close even after 1 year of operation. So those, I mean to say, that efficient lining life. Then again, going to the reduced downtime, again, we have already discussed into the third parameter that is all connected with that. If you are going to have a less repair and maintenance, then ultimately you have to down your furnace for equipment, any equipment, for less time, and having the less reduced downtime, which is directly affecting your production cost, means you can take more production. So these are the major goals, and how the refractory is going to be tech part, and how the refractory is going to be help out to achieve those goals, and finally you get the best result. So coming to the point, when we talk about lining, means refractory, whenever we deal with anyone and we talk about the lining or any refractory, we talk about the lining. So lining basically has the two components. We talk about the lining, but what the allied basically do is, what we talked about allied way is, we talked about efficient lining. It is not like only lining, but efficient lining. As I have explained that what about the efficiency? efficient lining. So let's going into the what we called about the efficient. As we discussed, it's a reduced energy cost per ton of the liquid metal. So the lining we have to design in such a way, or we have to select the product in such a way that it has to has the reduced energy with your equipment operation, whatever equipment you are operating. Then again, reduced frequency of repair, which is ultimately affecting your downtime, and ultimately you are going to have the production, more production time. Then maintain molten metal volume stability. What I have explained, like having the volume stability of same what has been designed into the beginning and for longer duration, that will directly affect your the energy consumption as well as directly affect your production. Then reduce cost of the lining means how we can work out to find out the best lining configuration, as well as the longer lining life, which altogether is going to be combined into the ownership of the cost of the lining. Then coming to the third point, fifth point is the ease of lining care. Like means you are working with the operation, the shop floor people are working on the equipments, but cleaning is one of the very minimum application or running those furnaces. These has to be done on very periodically manner. And we can say that cleaning is a very integral part when we are dealing with the aluminum melting, holding, or handling the liquid metal. So efficiently, all those together, if we are going to achieve, definitely it's going to directly reduce your production cost. So what we talk about efficient lining means lining is basically we can divide into two parts when we are dealing with the lining. One component is the lining product, whatever the products we are going to use into the whole lining system. And then other part is the lining configuration. We are having good products, all the good products. There is a lot of products being used into the lining, but if we will not be able to design the whole refractory system on, yeah, and that is basically a very important part into the lining system. See, we extremely sorry. I think there was certain poor network probably because of that we have lost. So coming to the point, what we have discussed about the lining, that lining was having the two component part. One is the products and one is the lining configuration. So we are just going through the lining configuration. So basically the lining configuration when we talk about is a combination of insulating backup and the hot face layer, the working lining. When we're talking about hot face layer, which is the layer or refractory castable, which is coming directly into the contact of the aluminum metal to achieve the efficient lining performance. So in understanding, you can see the different type of uh, furnaces here, which has been configured with the best possible lining configuration. And you can see different colors into the whole lining system that represent the different kind of the products. So basically, if we need to understand this in detail, we have just put a schematic that is just for the understanding purpose. There is no technically proven this, just for the information that how these refractory lining configuration and what are the important factors is going to be associated with that. So you can see this aluminum solidus temperature that called the freeze plane, and ultimately when we are going to work on the lining configuration, this is one of the part that aluminum solidus temperature that called freeze plane, and then steel cell temperature, outside steel cell temperature, that cold phase. Along with that, the whole the hot phase working lining how is it going to be best affect towards your melting and holding application. So here we have took like hot phase temperature, aluminum metal is like 700 C, and you can see the normal temperature profile. If we are having the general lining configuration, basically those travel towards that. And if you will see this LO9 aluminum solidus temperature, that shows that if somehow the metal has got penetrated into the lining system, at which place the aluminum liquid metal is going to be freeze and there is no further movement towards the steel cell. So if you will see that in the normal lining configuration, or you can say normal temperature profile, this the solidation of the aluminum is almost going very close to the insulation backup lining. But if we will see the expected temperature profile, means that is the what we have to achieve or what we have to consider when we are designing the whole lining configuration into the system. You can see the aluminum is being solidified here. It means it is into the hot phase system, that is refractory casting. So that is the best condition when we are designing into the refractory system, refractory lining configuration. Another thing is the steel cell temperature, which we will talk about later on into that part. So the whole system should be in such a way that you have to achieve these complete refractory lining configuration with the best aluminum solidus temperature of freeze plane into the hot phase. That is the best possible. Then we are going into the what we talk about the steel cell temperature, like thermal analysis. You, we have worked out on different options, that is just for one uh, lining system where there is a 75 mm board as well as the 65 castable in general. So altogether, this lining system is about 140 So uh, uh, this whole 140 lining thickness is going to be divided into the insulation backup and the hot phase lining system with the three option. And with the three option, you can see that where is the freeze plane depth, what we talked about earlier, like aluminum solidus temperature as well as the cold phase. How the change into the thickness and change into the product will directly affect these two parameters of freeze plane as well as the cold phase. Option one, we have considered 760 as a metal temperature, where the insulation board, there is a two type of the board being used. One is A and B. So when we are using insulation A board in the 50 and then insulation with 25 with the refractory castable of 65 the thermal analysis shows that your freeze plane will be into the 102 and the cold phase temperature, steel cell temperature is going to be 67. Since this is a very thin lining section, and so you are having the freeze plane little bit deeper, because here whatever we have designed this lining configuration, the priority was to have the high reduce cell temperature as much as possible. We can little bit compromise on the freeze plane. So how this cold phase is affecting? We just change the A insulation board to the 50 D board and keeping the same lining thickness, but you can see the steel cell temperature has been gone from 67 to 79 degrees C. Only the change of thickness of a different type of the board. A board reduced to 25 and B board increased by the 50 and it increased. The whole lining system, whole lining thickness is the same. Even the refractory castable is the same. Only the change in the insulation backup and that increased the cell temperature. The same way is the option 3. So what I, what we mean to say that whenever you are working onto the lining, you have to have the best lining configuration to achieve those optimum cold phase, whatever you have desired. And that needed to be designed with proper lining thickness and proper the product being used into that system. Then coming into the second part, that is products. here we are going to talk about only the hot face lining products. Insulation is the different. There are certain parameters we have to consider, but it will take a long time. So right now, I am just going to work on the hot face refractory products, which you can relate with the refractory castable, mostly used into that die casting foundry equipments, into the melting, transfer, or holding equipments. So when we are talking about the lining product or refractory castables, in general, what we have seen that the product selection or any the parameters being considered, like what is the percentage of the alumina into that refractory castables. That is true, but that is not all about to have to consideration. There are other factors we have to have the prioritize, and we have to have look on that, because percentage of alumina is something which just give you the reference point, but like the when we are selecting the lining product, we have to find out that where these products are going to be applied, where these products are going to be installed. So basically, those areas, what kind of the properties those products are needed, are going to run into that areas. So from where we can see those parameters and how we can relate those information from those mentioned into the product data sheet. So you have to see the maximum service temperature that shows that operating temperature means till what temperature those products can be efficiently worked. The density is related to the quantity, but after that, you will see, if you want to see the mechanical strength into your refractory castable, mechanical strength of the properties, then there are three parameters, CCS, MOR, and HMOR. Basically, the HMOR is the best important parameter, because HMOR is the hot modulus of rupture that shows that the product having the strength into the hot condition. So basically, you require the product or strength of the product into the operating conditions. So HMOR data is a very important. MOR is also because it is the modulus of rupture because of the thermal cycling, how good the strength is going to be retained. So MOR and HMOR is the data we have to consider when we are selecting the product. PLC relate to the volume stability, that at the different temperature when the thermal shock is going to be happen, how good those refractory is going to be intact into the system. Then abrasion loss is related to again the strength, because during the charging or skimming, those things are going to be affected. Then thermal conductivity is directly going to be affect your cell temperature. And non-wetting, this is a very important parameter when you are selecting the refractory product going to be applied into the metal contact area. Thermal shock, again, if the product has to be designed with the best possible, where you are having a very frequent cooling and firing the burner, that means cooling and hot condition very frequently. So the best design thermal shock refractory product is going to be give you the best result into that area. Then installation method, there are certain location, means there are different way to use those product can be installed, like vibrating castable, self flow. So there are a certain area we are very critical. So we have to find out either this product is suitable to for the installation into those area. So I mean to say that when we are going to select the product, uh, those are the properties of the product we have to consider apart from the percentage of the aluminum. You can see here when we are talking about the non-wetting, these are the three products which have almost the similar chemistry of alumina and silica, but having the different non-wetting agent and different designing of the product. So different designing of the product. So you can see the penetration when it has been tested. You can see the difference into the performance. The third one is going to be at the best, because you can see a very almost nothing uh, problem with the refractory when it is coming. But here you can see the little bit a dark color onto the surface of the refractories. So it doesn't it shows that it is not correct that every 80% or 60% non-wetting castable is going to be the same. It could be the different performance because of the designing and because of the different kind of the additives being used into the lines product manufacturing. So after getting through going through all the two factors of the lining system, like lining configuration and the parameters what we have to consider when we are selecting the refractory product for the refractory castables, and where we have discussed that the properties. Now, how those properties are going to be uh, addressed into the when we are talking about the lining system into the different equipment. Here is the one example like stack melter that called tower is tower melting furnaces. Basically, these tower melting furnaces can be divided into three sections. One is this charging, that is the soft area. Then one is the melting chamber, and then other is the holding chamber. And this is the sliding door apart from that. So basically, these are the three sections. And you can see all the three sections, these three sections is going to be work or going to be in different, operate into the different environmental condition. Coming from the top, where the charging area is happened. So here, the most important thing is the mechanical toughness when we are working on the refractive, which is going to be directly as a hot face, because that is the area where the uh, uh, charging scrap is going to be charged, and that is going to be heated on the lining system. So when we are selecting the product, we have to find out the product which has the better mechanical strength, and that is related to the HMO and MOR. Then abrasion resistance, that is another thing. Thermal shock, because those area is going to be very frequently cool and heat. And then again, the best volume stable refractory is going to be worked out, because if it is not, there is a lot of cracks and all those things is going to be happen, and that reduce the history. So when we are selecting the product into the charging soft area, these are the important factor. Coming down lower side into the melting chamber, again, the mechanical toughness is required because this is just attached to their charging area. But since here the melting is happening, so product has to be have, apart from those strength, has to have the non-wetting characteristic to the aluminum. Non-wetting package should be into the system so that it can resist the sticking of the aluminum and brass. Then again, the thermal shock and the volume stability, what we talked earlier about the volume stability, because if here in this system, if there is a lot of dross and corundum is going to be stick, that will reduce drastically your volume into that system, and that will directly affect your whole system of the tower melting production. So you can see the difference from the charging shaft to the melting chamber, what exactly you required as a hot face lining system. Then coming into the holding chamber, you can see the major and most important thing is non-wetting. There is a lot of things which we have discussed into the charging shaft and melting chart that is doesn't, non-wetting is the package which has. So you can see the complete system has the different environmental condition, and that has the different requirement. Then coming into the roof, that require the low thermal conductivity so that you can have the reduced steel cell temperature, the top surface, and the whole the reduced heat loss from the system. Then this is going to be mostly the burner area and the open area. Then alkali resistance is one of the factors which we have to consider when we are selecting the refractory product for the roof. The lightweight will be the additional advantage. Then there are certain stack melter which are having the sliding door, and those sliding door again, that has to be very lightweight because that is the moving, and that has to has the low thermal conductivity, so the heat should be pass less, and also the thermal shock resistance. So overall, it means shows that all the complete three sections, we have to have better understanding of the complete system, different environmental condition, and based on that, we have to select the refractory products. Then coming into the ladle part. So there is a, this is the top. You can see these are the general transfer ladle into the inside foundry. But below you can see a one that is called the road transport ladle, which is a very closed ladle system where there are certain practices that the liquid metal, ready liquid metal being supplied from outside third party to the directly to the die casting foundries. So the aluminum liquid metal travel through the road and supply to the die casting, that called the road transport ladle. And both have the different thing. What exactly we needed when we are selecting the refractory product for this ladle system? The sidewall, the non-wetting to the aluminum, and the thermal shock, because these are going to be uh, hot and cool very frequently, because after pouring, this is going to be cool, and when it is going to be again fail, it is going to be hot. So the thermal shock is going to be happen. Then when we are going into the bottom system, bottom of the refractory, because this is the what we call sidewall and this is the bottom. So in the bottom, non-wetting, absolutely it has to be, because it is the metal contact area. But since the metal is going to be directly fall down liquid metal into the bottom system, it has to be has the good strength, so that it can avoid the metal refractive washing because of the metal drop. Metal, liquid metal going through on the bottom system. Then abrasion resistant, and again the thermal shock. And then into the cover, if we are going to design over the cover, this cover, then insulation is going to be important role. Because you know that most of the time, and in the general, the most of the heat loss happens from the top of the liquid metal, top of the aluminum liquid metal. So the cover, which has been designed with the refractive system, which is having the very highly insulating, means low thermal conductivity, that is going to be the great advantage to keep your temperature intact for the longer duration. It means reduced uh, temperature drop during the transfer of the liquid. There are a certain I came across with the certain situation where the foundries need uh, is the reduced weight of the ladle, because there are certain operational practices, like they can handle this much of weight by the forklift. If in that case, if you're looking for that without affecting the whole your steel cell system, there are a certain refractories available with which we can configure those lining system with the same volume capacity, with the same steel structure, uh, uh, so that the whole whole weight of the liquid, whole weight of the ladle is going to be reduced. So like what it is like a combination of low density and high density product going to be installed into the whole system, and that is can be achieved. There are one case study we have done, that is 1 metric ton road transport ladle, where without affecting the steel cell dimension, without affecting the inner volume, the 250 to 300 kg of the weight has been reduced by uh, the selecting the combination of low density and high density products. This is basically the reduced weight ladle is related to the safety concern, because there are a forklift like being operated like it is designed to carry the 2.5 ton of weight. But if you are transferring the 1 metric ton of ladle, it means that your ladle should be under 1.5 metric ton, including the lining as well as the steel cell. So what we have came across with this 1 metric ton is around 650 to 700 kg is the average weight of the steel cell. It means that you have to have put the refractive system within the range of 650 to 700, around 700 to 750, not more than that. But it can be only achieved with the proper combination of low density and high density product can be used into the metal contact area. Then that is the third equipment, what we can say is the die casting, dosing, and holding furnaces. There are different type. There are certain crucible type, but here we are talking about the furnaces which has been lined by the refractory castables. So there are different designs by the different OEMs. So what are the major goals here? Again, the energy is the biggest part, and always goal is to how we can reduce the energy. Second is the corundum, which is the very prominent factors which affect the service life of not the refractory system, but the whole furnace system also, which directly affect to changing your heater and all those things very frequently. You can see these kind of the corundum growth into these kind of the furnaces. And then again, the reduced cracking and ease of the cleaning. These are the goals if we are able to achieve with these die casting dosing. It is one of the best, you can say, solution for the soft floor people, which make a very easy operation and ultimately achieve the reduced cost pattern of liquid metal, production pattern of liquid metal. So what exactly here we have done one of the case study with how we can achieve those goals what we have discussed, like reduce energy and all those things. There are certain products available. We have done the studies, like that is the standard high alumina refractory castable. Here we are talking about that how we can reduce the energy. The possible way when we are talking about reduced energy by the refractory, so it is directly related to your refractory lining system. If we are able to achieve the reduced steel cell temperature, it means that that is going to be directly affect the energy consumption, because whatever, if you are going to have the reduced steel cell temperature, means inside the temperature needed is going to be reduced for holding the liquid metal to maintain the liquid metal temperature. This is the one of the general uh, uh, configuration which is done formally for the just information purpose. Here you can see there is a standard high alumina refractory castable with this 6 mm CF paper, and with this almost 120 or 125 refractory castable thickness. And from the 760 hot phase, this is the liquid temperature, liquid metal contact hot phase area. So from 760 C, the temperature going to be dropped to the 526 on the surface of the CF paper, and finally 191 on the steel cell. But with the innovative high alumina refractory castable, which is currently available into the market, and by changing this one hot phase lining system, this insulation backup is going to be same. You can see that from the 760, the surface temperature over the 6 mm is reduced to the 375, and ultimately the steel cell temperature is going to be 139. Means it is a difference of 191 to 139 just by changing this refractory castable. Nothing changed into the insulation backup lining. So there is a products available, very low thermal conductivity product, high alumina, which meet the excellent non-wetting, which meet the demand of uh, reduced energy for the aluminum molten metal contact. When we are going to deal with the NRD corundum, what is going to be the possible factors which we have to consider into the refractory castable system? There are two main factors. One is the high temperature. Then there is the exposure of the alumina to the silica. How this affect? You can see there are two kind of the corundum growth is going to be happen. Like one is the external corundum growth, which is by default, this is the operational part where the aluminum need the environmental oxygen and that form the aluminum oxide. But what relate to the refractory castable system? How this refractory castable system is going to be take part into the corundum formation? So here you can see the aluminum react with the SiO2 present into the refractory lining system, which reduce the and snatch the oxygen and that form the aluminum oxide and get silica free. So that shows that if we have the SiO2 into the refractory system, lowest lowest possible, that will reduce the reaction of that alumina and reduce the aluminum oxide formation. So ultimately, we are able to achieve the reduced corundum formation. So that is something how the corundum is going to be relate with refractive system. Now, I'm just trying to show one of the case study of the standard low cement castable, like whatever 65%, 80%. But this case study is the 80%, one of the standard low cement non-wetting castable with the product what we have discussed that which can be reduced to your energy consumption, like innovative high alumina refractory castable. There is a 800 kg die casting dosing furnace which been in operation into the 7 month of the service. So we have taken both the reading on the date of 11 January 22, and you can see this was the reading with the very innovative high alumina refractory, and that is the standard. And after 7 months of the operation, this much is the reading, and you can see the consumption of the consumption of the energy. And when we differentiated that how much energy has been consumed between both the standard as well as the innovative high alumina castables, we have seen a significant difference of about 19,000 units less with the innovative high alumina refractory castable against the standard castable. And as you know that those furnaces not run for a 6 month or a year, those furnaces run for uh, more than 2 year, 3 year, 5 years, 6 year, even more than 5 years. So you can imagine that in the during the whole campaign of the lining system, whole campaign of the furnace, uh, having the reduced energy consumption of 19,000 in the 7 month, in the during the whole tenure of the lining operation, how much energy saving can be. It means for me it looks like the whole lining, the cost is going to be just payback just by uh, having the reduced energy consumption. So just think about that. That means there are refractory castable. When you are selecting the refractory castable, it is not like that always that uh, the low price product is going to be uh, always the best option, or you can say it's an economical option. Yeah, it definitely looks like into the beginning that it has the less cost, but just think about during the whole campaign of the lining life, sometimes the higher price product is going to be the less price production cost for you to the complete tenure of the furnace operation. There are another refractory castables uh, where if you feel that you need the furnace very fast into the operation that called rapid turnaround. There is a certain refractory is available, that chemically bonded refractory available into the market. So by this, you can speed up the installation of process, and you can speed up the heat up, and altogether what you are going to achieve is you are going to put your furnace back in a very less time into the operation, whenever it is specifically whenever you are dealing with relining or repair. So this is the one of the important development what we are going to have into the Indian market, like the gunning chemical bonded refractory. Basically, this is the best when we are going to have the repair needed the very frequent repair into the furnaces or anywhere, because by this you can see that there is no former, there is no mixer, nothing, no soldering and all those things. You have to just clean the lining surface, this gunning system, and you just gun over the refractory uh, over the old lining wall. And since these are the chemical bonded refractory, it's set very fast, and within a 4 or 5 hours, depend upon the area and all those things. You can just finish the installation and just get it set, final set within a 4 or 5 hours, and you can just on the furnace for the operation. Then again, the another inputs regarding that flooring product, because maybe you have been seen around your furnaces or around your ladle operation area that there are a certain concrete or concrete flooring, or maybe the brick flooring, but those floorings are being damaged very frequently, and that basically little bit obstruction, I can say, when uh, during the operation of the forklift or other operational factors. So there are a certain specific flooring material available, which has, you can see that, which has the higher strength, and the best part with those floorings are those are the non-wetting to that aluminum uh, splashes on the floor, because it just get easily come out without affecting the flooring. So it goes. Those flooring has the very high strength also. So mechanically also it is going to be less damage. So mechanically as well as because the metal is placed, both the way these are going to be less affected flooring, as well as whenever there is a certain sometimes there is a dross directly coming fall down over the flooring. So because of the thermal shock also, the concrete or brick is going to be damaged very fast, while these special flooring is going to be stay longer duration. In the pics, you can see these are the flooring around the stack area, and those flooring has been installed in 2011, and it is almost 12 years, and those floorings are still running what we have. So means those additional things probably can ease your operation, and whenever you are handling the moving equipment around the stack area. So apart from that, selecting the and working on the best possible lining configuration, best possible lining products, everything what we have done with the equipment. There are altogether, I can say is to choose the refractory lining product that have the optimal properties for the areas required into the lining of the furnaces, ladles, launders, and die casting dosing and molding furnaces. Work on the best refracting lining configuration, what we have discussed, have the refractory installed by the highest quality contractor. This is also one of the very important factors, because sometimes is I have seen somewhere the skilled contractor is missing, and even though if you have the very good quality of the product, if it is not going to be installed the way it has to be installed as per the proper procedure, absolutely it is not going to give the performance as mentioned or as been addressed by any manufacturer. Have the furnace dried or heat according to the recommended heat up schedule. That is also one of the important factors. Everything has been done, properly selected the product, properly configure the lining, properly install the lining, but we have missed the proper heating procedure, and everything will be vanished. So never compromise on the recommended heat up schedule. Hot clean the furnace on regular basis. See, This is the one of the very important factor when the lining is into the operation. And if it is not going to be clean as recommended or as required, means everything is going to be accumulated over the lining surface, and that is absolutely not recommended, and it is going to be affect the whole lining system. So in summary, we can see that refractories are specifically designed. There is a lot of raw materials, additives is going to be added, and then finally a product has been manufactured. Understanding each application area is very important, as we have discussed into the different products and different areas. Operating practices, furnace types, metal chemistry dictate the refractory performance. Highly non-wetting insulation castable can affect typical refractory lining design. Here we are talking about refractory lining configuration. The freeze plane theory, what we have called aluminous solidus temperature, minimize heat loss, combining both along with the non-wetting ability to increase overall. This is all about talking about the refractory lining configuration. So overall, to summarize that, we have to have give our best effort to find out the best refractive product, best lining configuration, best application, best operational practices, and ultimately, no chance that you cannot achieve your goals. So, concluding that, I would like to thanks again to IIF Chennai chapter, and if there is any question, I will be happy to try to explain or give the answer with the best possible my experience.
Thank you, Mr. Gulab. Now over to the audience. Raise the questions. Gentlemen, you can raise the questions now to Mr. Gulab.
So looks like no question.
I think people are satisfied with the presentation itself. Anybody raising questions? Please unmute yourself. You can raise the question.
Mr. N.K. Rao, I think you'd like to have some question. I'm not able to hear.
Okay, Mr. Gulab, if anybody wants to raise the question, let them send by mail.
Sure.
You can share the mail ID so that they can send the questions to your mail ID. Sakti, now you are online. You can you say a word of thanks?
Of course, Chairman.
Yeah, please.
So back to the end of the session. It's so interesting and very informative session what we have today to start the first program of the non-ferrous program. So I thank you for each and every one of you who participated, as well as for the today's speaker. It's very good program, sir, today, and also very informative. As I informed earlier, please make it into an article so that can be published in our Southern Region newsletter. So it can reach to the people who are not attended today. And also we will upload this video shortly into our IIF YouTube channel. So those who have not seen this calls are also be benefited with it. Thank you very much. Thank you one and all for each and every one of you who took part today, sir. Thank you.
Thank you. Thank you.
Thank you, sir. Thank you very much. Thank you.
Thank you, sir.
Okay, thank you everyone from my side, and again thanks to IIF Chennai chapter.